correspondingly, if you have a high voltage available, you could get away with quite a small magnet. So how small could you make one of these if you wanted a sort of portable radiation source?
It's a good question. I'll have to get back to you on that. Yeah. Like, really, you need a magnet that's at least probably half a Tesla for it to hold a decent enough spiral, so it's not just spiraling out after, like, 5 turns. All right. Oh.
Yeah. What's the power consumption of this thing in operation?
It's on the order of 2,000 watts about, so not crazy. It's like, you know, maybe 2 toasters, so 3 toasters.
You seen any radiation?
Any what?
Any Cherenkov radiation?
Oh, no, gosh. Because you get Cherenkov radiation if it goes from, It has to be in water, doesn't it, for Cherenkov radiation? Because you get that diffraction. So, yeah, in air, you don't get that. And also, I think they're not going fast enough for Cherenkov.
Anyone? There's no further talk, so shoot, as long as you want to. Till 9, I think. Okay.
Do you make some special treatment of the aluminum of the chamber to prevent gas emission or secondary electron emission when particle and ion hit the chamber wall?
A gas emission, or sorry, you said special treatment of the aluminum?
Yeah, because usually when you make some metal part for void environment, you heat it first to release all the gas that's stuck on the skin of the metal.
No, I didn't do any treatment of that to the aluminum, primarily because you don't have many particles hitting the aluminum itself, because they're spiraling around and the first thing they hit as they spiral out is the Faraday cup or your target. So you don't have that much radiation impinging on your aluminum.
Okay.
So there wasn't any treatment other than, well, there's some heat treatment to the 7075 aircraft aluminum, but for the 6061, there wasn't anything additional done to it.
Why do you accelerate protons rather than directly accelerating electrons?
Sorry, protons with...
Why do you choose protons rather than electrons?
Oh, well, the thing with protons is that they don't get up to high enough velocities, so you have to worry about Bremsstrahlung radiation, so it makes shielding a lot easier. With electrons, well, also for electrons, you have to deal with relativistic effects, and then also they're sending off the soft X-rays. So that was the main decision. Though it would be easy enough to make electrons if you want to. It would be easier, really. So you just have thermionic emission, and you don't have your hydrogen influx.
Okay.
So you just have your electron source like that.
Anyone else? No, okay. In that case, I would say thank you very much for the interesting talk. And yeah, thanks.